Today's lesson is about solving equations that have fractions. All right, so if you're like me, I hate fractions. I can't stand them, and just every time they're there, I just kind of wish they weren't. So I'm going to talk to you about ways to simplify things so that the fractions, you don't even have to deal with them. But there's many ways that we can look at equations that have fractions in them. We can look at a very standard equation with a fraction times a variable equaling a number. So there's no addition or subtraction going on. It's just a fraction being multiplied to a number. So one of the ways that you can you can solve that is you can actually multiply both sides by the reciprocal of the number in front of x. So in this case, the reciprocal means the flip of it. So I can multiply both sides by 2/3. The reason that is because if you did 2x equals 10, well then you know you divide by 2 on both sides. Well, if you do 3/2 equals 10, or 3/2 equals 15, well sure, you can divide by 3/2 on both sides, but look how funny that looks. And what you learned in pre-algebra was that if you did have a fraction bar, it was multiplication. So you'd have to keep 15, change to multiplication, and then flip the denominator. So that's actually the same thing as multiplying both sides by the reciprocal. What happens on the left is that the 2's cancel and the 3's cancel to the number 1. So you're left with x. On this side, you can put 15 over 1, and then you can simplify. 3 goes into itself once, 3 goes into 15 5 times, and then 5 times 2 is 10. So that's one way to solve an equation with fractions, by multiplying by the reciprocal. Okay, but you can only do that if it's just one monomial or expression equaling one monomial or expression. All right, then we have expressions that have like addition included with it. So this isn't the same as the last example, but I can make it the same by getting the 7 over to the other side, isolating the variable. So now I have 2/3p, 2/3 p equals 24. All right, so now I have that expression I like, a fraction times a variable equaling a number. So no addition or subtraction left. So I can multiply both sides by the reciprocal of 2/3. All right, these cancel and you're left with p. You put 24 over 1, so 2 goes into 24 12 times, and 12 times 3 is 36. Okay? All right, so those are some basic fractional equations. But look at this one. This one's got fractions all over the place. Well, you can't multiply by a reciprocal here, and you can't, you could try and add the fractions, but why would we even want to? So there is a process called clearing fractions. Now, if you're like me, I like to simplify things to make them easier for myself. Whether that be how I'm going to get to a friend's house, I find the simplest route, or if I go to the grocery store and I'm looking for things, I'm going to really try to focus on just all the things I need, making it a little bit simpler. Everything I do, I try to make simpler. So when we have equations with multiple fractions and multiple terms in it, one way to solve the equation, to simplify the equation, is to clear fractions. To clear fractions, you multiply every term in the equation by the least common denominator. The least common denominator. So in this case, you look at all the denominators, the lowest common denominator would be 6. So I'm going to multiply every single term by the number 6. All right. So I have 6 times 2/3. So 3 goes into 6 2 times. 2 times 2 is 4. So that first term now becomes 4x. And then there's a plus. So then I have 6 times 1/2 x. Okay? 2 goes into 6 3 times. 3 times 1 is 3x. I have 6 times 5 sixths. Well, 6 over 1, the 6's cancel, and I'm left with 5. And then 6 times 2x, it's 2x, they're both over 1, so it just gives me plus 12x. Okay? Now look at that. Isn't that an easier equation to work with? Well, I hope you're saying yes. So now I'm going to combine the like terms. So 7x equals 5 plus 12x. I'm going to isolate the variable, so I'm going to bring the 12x to the other side, and I'm going to get negative 5x equals 5, and then I'm going to divide by negative 5, and so x equals negative 1. Hopefully you're seeing how easy clearing fractions can be to make an equation simpler. And in Algebra 2, we're going to be dealing with a lot of equations with fractions in them. So it will be helpful to know this skill. All right, so let's go through the process. First, find the LCD, the lowest common denominator. Then, step 2, multiply the LCD to every single part of the equation to remove the fractions. So your equation will no longer have fractions in them if you did it right. All right, and then the last step would be to solve the equation. Now let's just remember that the goal, the point, is to get rid of the fractions. So let's remember that. All right, so we just did the first example. We're going to try the second one. We look at the equation and we look for the lowest common denominator. So if I were to make all of these have the same denominator, I'd be making it 8. So instead of making it 8, I'm going to multiply every single term by 8. Now, if you want to simplify how you write that, you could just write 8 one time. All right, so 8 times 7 over 8. Well, the 8's are going to cancel, and so you're left with 7x. All right, the second term, it's plus. So 4 goes into 8 2 times. 2 times 3 is going to give me 6. Equals 8 times a half. 8 times 1/2. 2 goes into 8 4 times. 4 times 1 gives me 4. All right, 2 goes into 8 4 times. 3 times 4 is going to give me 12. All right, now you have an equation that has no fractions in it. Oh, looks so much better. So now I'm going to combine the like terms. I'm going to isolate the variables. So I'm going to bring the 4x to the other side by subtracting it. I'm going to subtract 6 to the other side. I'm balancing the equation. So I get 3x equals 6 and x equals 2. Okay. You try. Now it says practice in class, but we're not in class. If we were in class, we'd be practicing this in class. So what I'd like you to do is look at that example, try it, and then come back and see my solution. Okay, so you tried it, and hopefully you saw that your LCD was 6. So I am going to multiply the entire equation by 6. Now notice this time I wrote 6 once because it got really, really messy. So I'm very careful as I do this. So I'm going to multiply 6 to 5 sixths. So 6 times 5 sixths. The 6's will cancel, and I'll get 5x. Then I'm going to multiply 6 to 1/2. 6 times 1/2 is going to give me plus 3. All right, I'm going to multiply 6 times 2/3. If I need to write it on the side, do so. 3 goes into 6, 2 times 2 is 4. Then I'm going to multiply 6 to that plain old 4. You have to multiply to every single piece of the equation. So I get 24. All right, now I notice that the 4 and the 24 are like terms, so I'm going to add them. Then I'm going to isolate the variable and solve the equation. So minus 3, and I get 5x equals 25, and so x equals 5. So hopefully you're feeling a little bit better about solving equations with fractions. Now I'm going to throw you for a loop. But what if it has parentheses and fractions? All right, so if you think about those first examples that we did, these values are being multiplied. So it's almost like this whole parentheses is like an x value. So I can get rid of the 5/2 by multiplying both sides by the reciprocal. So when I multiply both sides by the reciprocal, this cancels and I'm left with x minus 2 equals. Now, these don't have anything in common to simplify, so I have to just multiply across, and I'm going to get negative 15 over 2. All right, so now I'm in a really good place to clear the fractions. Now, you could add 2 if you wanted to, but you could also clear fractions. So I'm just going to show you how that would work. I would multiply the entire equation by 2. And I would get 2 times x is 2x, 2 times negative 2 is negative 4, and then 2 times negative 15 over 2 would give me negative 15. I would add 4, so I would get 2x equals negative 11, and then I would divide by 2. So x is equal to negative 11 over 2. All right, guys, so that's our explanation of clearing fractions, simplifying equations by clearing fractions. Definitely something we're going to be going over and using a lot in Algebra 2. So put some extra time into this lesson and that practice. Check your answers. And hopefully, if you have any questions, you'll reach out to me or Mr. Hamilton. Thanks so much.